All right, so let's talk about the homework 6.3. A little bit of a review, bringing everything back in. When we write an equation that represents each of the situations, we want to make sure we're taking careful note of, do I have an inverse, a joint, or a direct relationship? If I'm a direct relationship, that means that y is equal to some constant times x. If I'm an inverse relationship, that means that y is equal to some constant divided by x. If I'm a joint relationship, that means that y is equal to some constant, but I've got multiple variables happening that are with that constant in the numerator. All right, so w depends on, so he's going to be out here. W depends inversely, so here's my k, and there's my p, and directly with the square root of a. Because this is directly, it's up in the numerator. All right, so t varies jointly. T depends on some constant with r and the cube of c. All right, so here's this story again where we talk about they give us data and we're going to do one piece at a time. Z varies directly with m and inversely with j. This first part is where I write my rule. Z varies directly with m and inversely with j. Now for the second part, they give me some data. They say, hey, when m is 2, my k is unknown, my j is 4, z has a value of -20. So what I can do there is now find and solve for this k that shares this relationship. So when I simplify this, and then I'm going to multiply each side by 2, I say that k has a relationship of -40. So now for our third point is they want me to use that relationship to then solve for a future situation. All right, since I know that z is the result of this k that I found times m divided by j. So 24 is the result of -40 times m is -3. J is what I'm solving for. Then I can go ahead and solve for this relationship. They gave me z. They gave me m. I solved for k. So now this point here, j, is what I have to solve for. So I can go ahead and say 24 over 1 is equal to 120 over j. So that I know 24 times j is equal to 120. So j is going to equal to 120 over 24. So I'll go ahead and 120 divided by 24. So j has a value of 5. All right, the volume of a cone varies jointly with the height and the square of the radius. So the volume of the cone, there's my constant, varies jointly with my height and my radius squared. The volume is 83.78 cubic feet. Some constant I don't know yet, but my height is 5 and my radius is 4 feet. And remember, my radius is squared. So here, the only thing they're asking me to do is to find k. So I'm going to go ahead and say 5 times 4 squared is 80. So that's 83.78 is equal to k times 80 divided by 80. So then, of course, I know that k is going to be equal to 83.78 divided by 80. So k is equal to 1.0, round to 2 decimal places, so we'll call that a 5. when that round this one up to 5. Okay, number 5, which equation best matches the function? Looks like I have a horizontal asymptote here at 0, and that makes sense because I have more x's in my denominator than in my numerator. My graph looks like it was shifted 4 in the positive direction, so that makes sense to me to have an x minus 4. And now I have to determine, is it in the positive quadrants? So where does it sit? This looks like a reflection graph to me. All right, let's check it out again. We're going to have a horizontal asymptote of y is equal to 1. And that makes sense because each of these have 1 as a coefficients, the ratio of the coefficients. I have a vertical asymptote of -2, which means that this graph had a positive 2, so we'll cross off those. And now we're going to look at our intercepts. If I have my intercept of an input of 3, gives me an output of 0. So when I look at my table of values, if I have an input of 3, I get an output of 0. So my zeros are going to be determined by the numerator of my fraction, which means an input of 3. So we'll go ahead and say that D is our best answer for this one. All right, so we're going to describe our transformations. This negative means that we have a reflection. This -2 is going to mean that we go this way to the right 2. And this +3 means that we go up 3. All right, let's take a look at this one. We don't have any reflection. We don't have any left-right. The only thing we have here is down 5. And because our numerator is a 2, we're going to call that a stretch of 2. It's a vertical stretch. All right, let's check out the graphs on the back. Now for each of these, I want your first step to be to go ahead and enter it into the graphing calculator, come back and check my work. All right, so let's see how your graphs compare to mine. For this first graph in number 9, I have the same number of x's in my numerator and denominator, so my horizontal asymptote is going to be the y is equal to a over b. The coefficients of the x values help me find that value. And there's that purple line right there. My vertical asymptote is going to be where my denominator is equal to 0. So I'll go ahead and set 4x plus 2 equal to 0 and solve for x. And I get a vertical asymptote of x is equal to -1/2. I entered this into the graphing calculator and I was able to see where my points were, and I graphed xy ordered pairs on either side of the asymptote. My domain is all the x values up to my asymptote, jumping over it and continuing. My range values is all my output values up to, jumping over and continuing on. My x and y intercepts are going to come from the table of values. My end behavior is the same as my horizontal asymptote, making sure that we recognize that this horizontal asymptote tells me what's happening with my output as it continues on. Yes, it's a function. Yes, it's one-to-one. No, it's not continuous because I can't trace the whole graph without picking up my pen. There are no extremes, minimums or maximums. I don't have any hills or valleys, and my graph continues on. It is always increasing, never decreasing, and no constant parts. Taking a look at number 10, I have the same number of x's in my numerator and denominator. So again, my horizontal asymptote is going to be that A over B relationship. And there it is way up there at 3. My vertical asymptote is going to be where my denominator is equal to 0. My domain, all these x values up to, hopping over and continuing on. My range, all my y values up to, hopping over and continuing on. 0, 0 is going to be my x and y intercept, and my end behavior approaches that output of 3. 11 and 12 are a little more difficult because with each of these I have a quadratic in my denominator. So having that quadratic means that I need to spend some time factoring to find those vertical asymptotes. So when I find them, I have 2 vertical asymptotes, and depending upon where my x's are, my graphs are pretty crazy looking. So you absolutely have to be depending on the graphing calculator to help you figure out where those values are. Your horizontal asymptote, here I have more x's in my denominator than my numerator. Same with this one, so I have y is equal to 0 for my horizontal asymptote. Once I factor, I get my vertical asymptotes. I go to the table of values, and I can verify those with my errors, and then I can use the points on either side, left or right, to understand where my output is going to be. When I look at my zeros, and I can go ahead and I can see this range is an important one to think about, because with this quadratic denominator, I actually end up crossing the horizontal asymptote. That asymptote applies to these end parts of the graph, but not that middle. What's interesting here is if you notice we skipped the range. It is very difficult to figure out where this point stops and starts unless it's given to us as a vertex. That's a more complicated pre-calc conversation. All right, come to class with questions. We'll see you.